Okay, so when I'm looking at a sine function, the first thing I do is I think about the pattern of sine. So if you look at your unit circle, the sine of 0 degrees is 0. So sine, and I always kind of write the pattern. If you were in class Friday, you saw how I graphed that. I'm just continuing that. So sine starts at the middle, then it goes to the top, then it goes back to the middle, then it hits the bottom of the wave, and it's back at the middle. So sine starts at the middle, ends on the middle. Okay, and that's really, really important here. So just keep that in mind. Now, the first thing you want to do is notice how this says x over 2. So this can also be written as, this is really the same as saying 1/2 times x minus pi. Because when you divide something by 2, you're multiplying it by 1/2. That's what you're doing right there. And remember, to find the period, you have to take the formula for period, write this in your notes. And again, the period is how long it takes for it to do one full revolution. It's 2 pi over b. So let's label our transformation. So this 3 is your A value. 1/2 is B. You actually have to set the parentheses equal to 0 to get the phase shift. And then K is -1. So let's find the period. So to find the period, you're going to take 2 pi and divide that by 1/2. So who remembers how to divide by a fraction? Keep, change, flip. So when I'm dividing by a fraction, it's keep. Because if I'm doing 2 pi divided by 1/2, that's the same thing as saying 2 pi times 2 over 1. So when you divide by 1/2, you're really multiplying by 2. So this one has a period of 4 pi, which is 720 degrees. So it takes double, because normally in the parent function is 360 degrees. So this is going to take twice that. It's going to take 720 degrees for it to go around and do one revolution. So the period is 4 pi. So I'm going to count by 90s on this one. I usually count by 45s, but on this scale, I'm going to count by 90s, because when your period is 720, unless I had a longer x-axis, it's kind of hard to graph that. So I'm going to count by 90s on this example. And if you look at your homework that I just passed out, there is one that has a period of 4 pi. I believe on the back, I would count by 90s instead of 45s, just to make it easier. Okay, let's go ahead and find our phase shift. So to find the phase shift, take your parentheses, I'm going to have to erase to give myself some space. So take your parentheses, which is 1/2 x minus pi equals 0. Let's solve that for x, because that's going to tell me where to start the wave. So in order to solve this, I would add pi to both sides. And then I would multiply by 2. So I'm going to start this at 2 pi. So my phase shift, because x equals 2 pi, I'm going to start this at 2 pi. So this goes to the right, where it says horizontal right, that it goes right 2 pi. What is the amplitude? The amplitude is 3. The K value is -1, so it's going to go down 1, which means your midline is at y equals -1. Okay, so we're going to start this at 2 pi. So 2 pi is the same as 360. I'm going to go ahead and label this. So I'm counting by 90s. So let's see, where would 2 pi be? So this would be 90, 180. So this is my start. That's 2 pi on my axis. It's just always a little trickier when you have a longer period because you have to extend your x-axis. Because what this is saying is we're going to start it here. This is my start. I'm going to start here at 2 pi. And then because the period is 4 pi, I'm not going to end until I get to 6 pi. So I have to extend it out just a tiny bit. We almost made it, but just extend a little bit out. So from there, the rest is easy. Because I'm going to start it on the midline. Okay, so sine starts at the midline, and where is the midline? The midline is what? I didn't hear you guys. All right, so every place, so I'm going to start this at -1. So where I'm at 2 pi, go ahead and put a point at -1. And then it also ends at -1. Sine is a lot easier to graph, I think. So it starts at -1, it ends at -1, and then dead set in the middle, which will be 4 pi, is going to also be -1, according to the pattern. And then in between, I hit the top. So the top is, I have to add the amplitude. So if my amplitude is 3, I'm going to go up 3 to get to the top of the wave. So put your pencil on 3 pi and then go up 3. So up 3 would land at -2. And then at 5 pi, we're going to go down 3. So go down 3. So 1, 2, 3. And that would be your revolution. That would be one period of that graph. So then to just continue that pattern, let me switch to a different color. So that means at pi, I'm going to go down to the bottom. So every 90 degrees, or every 180 degrees, every 180 degrees, I'm going to put a point down. And I'm just following the pattern of sine. Oops, that was too high. So my domain, every sine and cosine are the easiest to graph because your domain is always the same. It's all real numbers. Sine and cosine are the only two of the 6 that have a domain of all real numbers. The range is your lowest y value. So how low do I go? So my lowest y value is what? -4. And the highest y value is 2. And that gets a bracket. And that is example 5. Look at example number 6. So again, first thing I like to do is identify the key characteristics of this graph. This is another sine. So sine starts at the midline, goes up to the top. It's a midline, you get to the bottom. Okay. So looking at this equation, the amplitude is 4. So I'm going to write that down. Amplitude is 4. The midline is at +1. So this graph, the y value that it's going to start at is 1. Because sine starts at the midline, and the midline is k. So this example starts at 1. The y value, the starting y value is 1. So it's going to shift up 1, and your midline is at y = 1. So let's find the period. So the number in front of x is 2. So go ahead and take 2 pi and divide that by 2, and you get pi, or 180 degrees. So for the shorter periods, I'm going to go back to counting by 45s. The only time I count by 90 is if I have a period of greater than 2 pi. So I'm going to count by 45 again. So let's figure out where this wave is going to start. So where do I start this wave? To figure out the start, take your parentheses, which is 2x minus pi over 2. Set that equal to 0 and solve that for x. So when I add the pi over 2, I get 2x equals pi over 2. And then I'm dividing by 2, which is the same thing as multiplying by 1/2. Multiplying by 1/2 and dividing by 2, that's the same thing. So I end up with x equals positive pi over 4. Which means that because it's positive, that means I'm going to go to the right. Pi over 4, which pi over 4 is the same as 45 degrees. So this wave is going to start here because this is my pi over 4, because remember I'm counting by 45s. So this here is pi over 4. And then it ends 180 degrees later. So that's only 4 hops. So 4 hops from this point is the end. Oops. Okay. So if I count 4 hops, so 1, 2, 3, 4, that is my end. So my entire wave, because this is a lot shorter. Okay, so we just need to know our pattern. So if you know the pattern, what does it say? What do we do for sine? We start at the midline. And where is the midline of this wave? What is K? 1. So put a point at 1 at the start and at the end, because that's my midline. And then sine hits the midline again directly in the middle. So midline 3 times. And now in between here, because my amplitude is 4, I want you to count up 4. You're going to count up 4 to hit the top of the wave. So it goes all the way up to the top, which is 5. And then in between here, you are going to count down 4. Sorry, I'm a little tongue-tied. So 1, 2, 3, 4. So this is what that wave is going to look like. Now continue that pattern out. So that's 1 revolution. So now see if you can continue that pattern, because it's just a pattern. It's the same 3 numbers. Remember, don't put any arrows, because arrows indicate that it goes up to positive infinity or down to negative infinity. And this wave does not go up to positive or down to negative. And you only have to add an additional 5 points. So you don't have to do the whole graph. So you have 5 points for your original graph, and you need to do 5 more points. But because I kind of like it, I just do a lot because I think it's fun. Although it is a little bit harder to graph on the iPad for some reason. I don't know why. So I'm not going to do the whole graph. Okay, so your domain, sine and cosine, has the same domain. So that would be all real numbers. Your range is your lowest y value, which is what? What is my lowest y value for this wave? -3. And the highest y value is 5. So take out your example 4 because you have 15 minutes. And you have 2 teachers that can help you get started on it if you have questions. So I want everyone to take out your homework 4 and let's get started. Because the only way to be good at it is to actually do it. Math is not a spectator sport. You actually have to participate to become good, especially if you're not happy with how you did on the last quiz. Then you want to make sure you blow it out the park, get an A or B on the next test. So take out homework 4. If you need help getting started, you have 2 people here who can help you. Tomorrow we are going to continue with the other 4 trig ratios.